Alright, so in this video, I'm going to show y'all how to use regression to test for moderation. So again, the same concept that we talked about before with moderation. We went over it in ANOVA, in factorial ANOVA, but now we're going to have a lot more flexibility, and so we can look at things like continuous by continuous interactions, or a number of different possibilities. But today we're going to go over continuous by continuous interactions, and I'm going to use the same example that I used in class. I'm just going to have this video so you can watch it over and over, or as much as you want. So let's say that we want to look at age and work time as individual predictors of estimated raw likelihood. So we'll just call this estimates. So we can look at the individual effects of these, and we can certainly do that using the same techniques you've gone over, like multiple regression, and it'll tell you whether or not there's a main effect for age, or whether or not there's a main effect for work time. But it's also possible that age and work time interact to have some interesting and unique effect on estimates over here. Now, in order to do that, we're going to have to create a product term, so basically multiply these two. But remember, in class, you have this issue of multi-collinearity. So before we create the product term, we need to center these variables. So in order to do that, we're going to go to descriptive stats. We'll go to descriptives here, and then we can click on, let's see, on age and work time. Bring those over. I can save these as standardized values if I want. In fact, we're going to do it this way just to save on time a little bit. So we'll click OK. And then we've got Z work time and Z age. Now, this saves a lot of time, obviously. It does it in one step, and then it's renaming the variables, so everything's basically done for me. The other option here is to go to descriptive stats, descriptives, and then do this without saving the standardized values as variables. And if we click on that, again, it's going to give us the same output, it's just not saving the data as a standard score. And if I wanted to center them without standardizing them, I would just go in and create new variables, right? I would create centered work time by taking each score and subtracting the mean, so 102.16. And then to create centered age, I would take each score subtracting 31.96. Okay? So we've got our standard scores. They have a mean of 0, so they're perfectly fine, and they have a standard deviation of 1 now. So in order to create the product term, we're going to compute variable. We're going to go Z age by Z, work time, and then we're just going to literally multiply them. Alright, so now we've got our product term here, and in order to look at the possible interaction, we're just going to enter that in the same step. So we go to Analyze, Regression, Linear. The dependent variable is just this raw estimate, and then we're going to bring over these two, and then the product. So after that, you can click OK, and then we can look to see for the presence of an effect. Now, as you'll remember from earlier, there was not a main effect for work time. There was a main effect, so not a main effect for age, and then there was an effect for the interaction. So there's a statistically significant interaction here. Now, in order to look at that further, we have to look at what are called simple slopes in regression. So to do that, we've got to find high and low values. Now, because we looked at the z-scores, it's one step is removed from this. So if I need to create a high and low for age here, if I think age is the moderator, it's much simpler because I don't have to find what the standard deviation is. I already know what the standard deviation is. It's 1. So I go to Transform, Compute. I need to find z low age, And again, remember, I'm taking age here, and I am subtracting 1 from that. Now, the reason it does this is because when you run the regression, any effect, if we go back here and look at the output, the effect of work time here, that is assuming an average score for age. So it's taking everything else at its average. So the effect of work time is at an average level of z-score age, which is 0. Okay? So that 0 is really meaningful. So if I want to look at the simple effect for perhaps a low age, I have to make sure that those low age scores, whatever that grouping is set at 0 again. And in order to get that at 0, which would be the average, I have to add values to it. So I have to add values to those low scores to get them to 0. So if I go back here, if it's a low age, then I've got to add 1. Okay, so to get a low age, I'm adding 1. 1 being the standard deviation because they're all standard scores. Now, in order to get the high variable, I'm just going to change the name. I'll go over here and subtract 1. Click OK, and now I've got those variables. So then I've got to obviously create the product terms. So z for high age times z for work time and we'll just do the same thing for low age. Alright, so we've got all these new variables created. And now I am ready to run the regression analyses again. So work time stays the same, but I'm going to remove age because this is the standard, the mean age originally, and then we've got the product term for that corresponding age group. So then we'll do low age first, and then we also need its corresponding product term. So z-score for work time, for the main effect for work time, we've got low age and then low age by work time. So when I analyze it, most of these things should be the same. Right? This interaction is going to be the same, 0.030, 0.030. We've also got 0.606 for the z-score for an age, 0.6606 here, so those are the same. What I'm looking for is what is the effect of work time for low age? And right here you can see that it is nothing, basically. The t statistic is below 1. The beta is very small, the p-value is quite large, so no effect for work time at low age. Also, if you look up here at the original analysis, there's no effect for work time at the medium age, at the average age. So then we go to analyze again, and we're just going to look at high age. So remove those two, we'll bring over high age, its corresponding product term, click OK. And here we have a statistically significant effect of work time for the high age group. So only at the high age group are you seeing this effect for work time. Now that is basically looking at the simple slopes. So in this example, this would be that age fully moderates the effect of work time on estimates. And then you can look at the trend. So for the high age group, as work time increases, estimates are going to decrease. Now, in the next video, I'm going to show you how to plot this out in Excel, and hopefully, that visual example will be a little bit more tractable for you.